Testing, testing. Welcome to Programming Rainbow. In this video, we're continuing on the series of Minesweeper in C and SDL3. This is the 11th video. If you want to follow along with this one, you can go to github.com, and this will be github.com Programming Rainbow, Minesweeper, -C, -SDL3. You can git clone that repository, move inside the directory, and you can follow along with this video. So let me just show you what it's going to look like. Like I said, if you are just cloning it right now, since this is the 11th video, you're going to want to delete the source directory, which will have the final code in it. You want to copy video number 10 and rename it to SRC so you can follow along with where we are here. I'm going to go ahead and compile the final code, show you what it looks like. Okay, so this is Minesweeper. We got seconds counting down. We have how many mines are hidden under here. This is the indicator of mines minus how many that I have indicated. So if I put a bunch of these mine indications, the number goes down. That does not mean that these are correct. They're just saying minus the indications that I've made. That's as to normal Minesweeper. If I click on a square, I get the face, right? If I, but I unclicked up here. If I click on it normal, it's going to show me what's under it. And this right here is a mine. This is not a mine. So this one indicates that one of the squares touching it is a mine, which is this mine. If I click it, the game's over. Okay. And we have different sizes. I can display the same one into a different size. I have different themes, right? And we even have the flower theme. And I have different actual game sizes. And we have different difficulty levels, which increases the number of mines here. So let's just see, there's a lot more mines in here. There was 96 of them this time. So there's lots of different options going on with this one. And let me just show you where we left off with. So normally the way you would compile this is I say make clean just to make sure, because I'm switching directories of what I'm compiling, make clean. And then I do release run. You can just say make run. Or if you have some prior code that's been compiled against a different directory, you can say make clean run, however you want it, but I'm doing release just so it's a little stricter. So this is where we left off right now. So we have the two indicators up here, but they don't do anything. The face does reset. So we can do this, but when we click on a mine, it doesn't end the game. The game keeps going. And, you know, so it just basically says that. And we can click and reset the mines. So in this one, I want to finish just making the actual game work. So we're not going to worry about these indicators here. What we want to do is, if the game is over, we're going to get the frowny face here. We can't click anymore. If the game succeeds, we get sunglasses face, and it's going to show us where, you know, like what's going on. So that's what we're going to make happen. So we're just going to make the game actually work because it's almost there. We already have revealing of the, you know, what's under the spot correctly and the algorithms to find out the other ones that we need to uncover. So we're just going to continue on with that and make the game actually run, but we're not going to be dealing with the indicators in this one. So I'm going to close this. So we are going to add a couple things. Let's see. I'm not sure what I want to add first. Just want to look at my notes. There we go. Yeah, there it is. Yeah. So I'm going to have this, going to be dealing with game state inside of the board just because I need to know if we've won, but it's going to be in the board. So what I'm going to do is just going to create an enum and board header and board H. And initially in my final code, I'm just using an int, and I use -1 for fail, for you lost the game, 0 for the game is playing, and 1 for the game has been won. But what I'm going to do is just use an enum instead, make it a little bit easier. It's more explicitly, I know, what state the game is in instead of just remembering numbers. So let's go enum, and I'm going to call this game state. And the reason why I'm naming it like this is because I'm naming it the way I do the structs, where I use the capital camel case. Okay, that's just the name of this enum. I'm not going to type def this. I don't really like type defing. So this is going to have 3 items in it, which is going to be game play, game won, game lost. And I'm going to give them all caps, kind of like I would do a pound define. That's just my... You don't have to follow this. That's just my style. Like, you don't have to make it all capitalized. But for me, I feel like it's more like a constant. So I'm going to name it like that. So there is that's our enum right there. And what I'm going to do is I'm going to add that now as a member. And I'm just going to call it game state. Like that. Game state. And I also need to know if I don't want the game to be able to be won or lost on the first turn. So if you click down and you happen on your very first click down for it to be a mine, that's not going to happen. What it's going to do is I'm going to replace the board right underneath you before I even display what's there. So you won't ever actually see that there was a mine underneath you. So I'm gonna keep track as if this is the first turn or not. Okay, so that would just be a bool. So those are just the 2 things I'm adding here. And with this enum, it does need to be above this struct because I'm using it here. If I put the enum below it, it's going to complain. So, and also this enum is going to be used inside of game, but I'm already including board H in game, so it's going to have access to the enum. I thought about putting it in the main H, but it doesn't really need to be seen by everybody. It only needs to be seen inside of game and board. So I'm just going to put it in board H. I'm just looking at my notes again. Sorry. I feel like I'm missing something here. Oh, I know what it is. Okay, so let's go into board C. And why is this? Wait a second here. This does not look right. Sorry. Oh, I know what I'm doing. So I'm looking at my notes, but I'm not looking at board. I'm looking at border. I'm like, why does this look totally wrong? I'm looking at this file here instead of this file up here in my notes. This is just, I'm just spaced out for a second there. Sorry about that. So down into the reset, since we have this first turn, and let's see, we do need to kind of turn that first turn on, and also change the state of the game. So right up here, we are already calling reset, and later on we'll call reset as well. So those 2 states need to be set there. They need to be set initially, which is fine because we're calling reset. But anytime we reset the game, they also need to be reset. So we're going to put them in reset. Here's reset. I'm just going to put it at the bottom. And I'm just changing the state of the game state and the first turn. So B first turn, I'm just going to have it be true. And then B game state, I'm going to have it equal to game play. That's like it's playing, the game is playing. Nobody has won or lost. Okay. And then we will, I do actually want to return this game state as well. So I'm going to, down here, right above board is pressed, I'm going to create, I'm going to return this enum. So it'll be called board game state. And this will be const. And sorry, that's the only one. And this will just return game state. Okay. So that's just like a little getter thing. So I'm not accessing it in a way that could be changed. So this is just getting that it's going to be used in game. So since this is going to be used in game, I'm going to grab this signature here and put it in the header file. And it was right above this one here. The board is pressed. It's not important in the order, but I just kind of keep it in order. Okay, so we have that. Now we have this basically we know if it's a first turn, and we also are able to get the game state in game. Okay, so we'll just keep going. Now we do need a function that we're going to check to see if the game has been won. And I'm going to put this down below the board reveal. Oh wait, I don't even have the board reveal yet either. Hold on. The pop check. Down below pop check right here. So basically we need to, if we lose, we want to reveal the board. And I'll kind of show you what's happening here. I'm just going to compile final code. Right? So if we win, so I'm going to make it lose. And you'll see it's going to uncover there. So when we lose, not only do I need this mine indicated, let me do it again, actually. I'm going to indicate a mine, a couple mines, right? There we go. So it's going to tell me the mine I lost at. It's going to tell me where the rest of the mines were. And it's also going to tell me the mines I've indicated as being falsely indicated. Okay. So that's what I need to do. I need a function that does that. Basically, it reveals the board when you've lost. It's revealing the board. It's, I have it called board reveal, but it's just like it's the losing part. It's revealing when you've lost. There's also another function that checks to see if you've won. So the way you win in this game is by turning over all non mine pieces. So anything that's not a mine, you need to reveal it, and that's the way you win. That's the only way you win. So basically, I have another function that checks to see if every back is equal to the front. If it's not a mine. If it's a mine, it can be marked as a mine. That's fine. But if it's not a mine, it can't be marked as a mine. You can't win in that state. So basically, any non-mine board, the back needs to equal the front. Even if you have a question mark, that won't work. You won't win. Okay, so we need to set up those two functions. So under board pop check, I think that's where I put it. Yes, I did. I'm going to first make the reveal function. So this is just a void. This is just, it's not returning anything. It's just it's revealing where the mines were. Yeah, I'm coding. Yeah. Let's see here. Sorry about that. Every time I'm click over, I have the pages stacked on top of each other. So if I click them in the wrong order, then one of them's buried, unfortunately. Anyway, the board B. Okay, so what we want to do basically is loop through the entire board, and anything that is a 9, if it's 13 underneath it, I'm going to turn it into a 13. That makes sense. So basically, any piece of the board. This is if we've lost the game. We've lost the game. Any piece that has a mine underneath it, I want to make the mine on the front board. If it's on the back board, a mine, I want that mine to be on the front board because I'm revealing that mine. If I have indicated a mine on the front board, with a 10, is the 10 indicating the mine? Let me just check real quick. I forget the numbers off the top of my head. We could have set this up as an enum too. So right here, so 9 is nothing, and this is me indicating it's a mine. So if I have indicated a mine where a mine is not at, then I'm going to use this one right here. So basically, if it's a 9, I'm going to check the backboard and see if it's a mine. And if it is a mine, I'm going to set the mine to the front board. So it's going to replace this with the mine. If it's indicating a mine, so if it's a 10 and the backboard is not a mine, I'm going to change it to this one. If it is a mine, I'm not going to do anything. I'm just going to leave the indication there. I indicated a mine, and yes, it is a mine. But if I was wrong about it, it's going to be no mine. If it's a question mark, nothing happens. That's the logic. So I'm checking if it's a 9, and then the back is a 13, the front's going to be a 13. If it's a 10, and the back is not a 13, then it's changing to a 15. Yeah. Hopefully that makes sense. So right down here, board reveal. So I'm going to loop through the whole board. I'm just going to steal one of my loops. Or not. Huh. Okay. I guess I'll just write it out. Oh, right here. Here's one. Yeah, just use this. Oink. Okay, where is it? Down here. So we have our for loop, and we're doing rows. Yes, as long as it's smaller than rows. Plus plus. Yes, that's correct. Column. All good. Okay. So the first thing we want to do is check if it's a 9. And I already have this. We are checking the front array. So I can just keep this here and say if front array, and we need to add another equals here. But I also want to check, not only is the front array 9, is the back array 13. So I'm going to put this here, and I'm going to grab this again. But I want this to be a 13. So if front is 13 and back, or front is 9 and back is 13, that means I need to go ahead and show that there is, in fact, a mine here. So I'm going to change the front array to 13. Get up there. There we go. Okay, so that looks correct. Or it did look correct, but it's not, because I didn't put a there. And this is, yeah, sorry. I'm not checking equality, I'm setting. So here I'm checking equality on 9 for the front. I'm checking equality on the back for 13. And if it is 13, if both of these are true, because I use the double ampersand for the logical and, then I'm going to set the front array to 13. So that's the single equals there. And the other condition I want to look at, I'm just going to grab this because it's going to be similar, is if the front is 10. If the front is 10, I'm indicating a bomb. So, and then what I want to know is not if the back is 13, but if the back is not 13. So I'm going to do bang equals. That means it's not equal to 13. If it's not equal to 13, I'm going to change it to a 15, which is the false mine. Okay, so that's the whole function right there. And this board reveal and check, are these on? These are not exported. Yeah, these are not exported. Okay. So I'm just going to put this one up above and do the next one. Okay. I mean, we could use this to reveal. I kind of just want to make the next function so we can put the two together. But you can kind of see what's going on here. I'm just checking the front array. If it's a 9, that means it's an uncovered. It hasn't been messed with. The back is a mine. So now the front needs to be a mine to reveal it. This is revealing for game over. If the front I indicated a mine, but the back is not a mine, then we have this false indication, which should be a 15, not a 14. Okay. And so the next function that we need is another not too big, small one. Here it is. This one, all we're doing is checking to see if anything is not a mine, if the front equals the back. Okay. So if all non-mine, basically all non-mine squares have been revealed. So if it's not a mine, it has been revealed already. If that has happened, then we've won. So this is just checking the state of the game. And this isn't returning anything. This is actually just setting a game state inside of it. We could do it the other way, but it doesn't really matter for this one. We already have B, a pointer to board, so we can do it this way. So this is also void, and it's going to be board check 1. And this is struct board B. And all we're doing with this is looping through the whole board. So I'm going to grab this up here. I'm going to add the 2 closing. Okay. Now I want to look at if it's not 13. So this is going to be back array. Row column. And it's a bang equals because I want to make sure it's not equal to 13. 13 is the mine. So we're making sure it's not a mine. Okay. So if it's not a mine, the back board needs to match the front board. Okay. If it doesn't match, then we are not in game over state. This is a Minesweeper. Here, I'll just show the game again real quick. So this is Minesweeper. You're trying to find mines. You click. This is a mine right here. If I click up here, I'm fine. But if I click right here, game is over. And that's what we're setting right now. We're checking to see if we won. So basically, the way you win. So I'll try to win real quick. If you don't know what Minesweeper is, it's been around a long time, but maybe it's only for old people. I don't really know. So I just won. He's got the happy face, and it revealed all the mines to me. that's the winning state. So that's what we're setting up right now is the winning state. And the way it checks the winning state is I basically uncovered everything that was not a mine. All of these mines were still covered. I could have indicated them to be anything. It doesn't matter as long as everything that wasn't a mine was uncovered. Okay. So that was the function that we're setting up there. So if it's not a mine in the back array, I'm looking at the front array. Or I'm looking to see if the front array equals the back. Column. So what we want to find out is if this doesn't. So we just want to make sure, is this not equal to, and I've messed up here. And so this has got to be the front array. Because what we're doing is we're bailing out early on this one. So if these are not equal, then we have not won the game. So I can just return out of this function right away. Right? If we make it all the way through this and we haven't returned yet, then we have won because every back did equal the front whenever it was a non-mine. So in this instance, we're just going to change the state of the game. So this is a game state. We're going to equal to game 1. Yeah. Okay. So that's how we're checking to see if we've won or not. We're just running this function. It goes through the whole board. It says, is it a non-mine character? If it's not a mine, does the backboard equal the front board? If it doesn't, it bails out. If it gets through the whole board and it never bailed out, then it's changing the game state to game 1. Okay, so those are the kind of the two functions we need to set up. So in here now, let's see, are we in mouse down? Not mouse down, but mouse up. This left, when we get down here, when we're checking the left button, if the button is the left button. Oh, so you just revealed yeah, you just turn over non-mine. So use the numbers. I'm just going to show it again real quick. Okay, so let's make it bigger. So when I click somewhere, this is a 1. This 1 says one of these squares touching it is a mine. That's pretty safe. I can click somewhere else and I have a 1 in 5 chance of it not being a mine, basically, because there's 5 here and only one of them is a mine. So if I click here, okay, now I'm a little bit worried, so I'm going to click over here. I'm just trying to get a start somewhere. It's not going very good for me this time. There we go. Okay, so this definitely is a mine and this is not a mine because this is a 1 here, which means this is a mine. This is a 1, which means this is a mine and this can't be a mine because that's a 1, right? Now, this is a 2. These are both mines because this one here says that's a mine definitely because that's the only way that could be a 1. But this 2 here can only touch these 2. So these are both mines. This over here is not a mine because this 1 is touching this, not this. So that's right. Now this 2 indicates these 2 mines here. We already know are mine. So this is not a mine. Right here, this is a mine. And so this 1 also indicates a mine. This cannot be a mine. Yeah. This 1 right here is only touching 1 square. That has to be a mine. This 1 is touching this mine, so this cannot be a mine, right? And this 1 right here, everything is touching other than this is not a mine. So I can go bang, bang. This 1 here is touching mine here. I can go all the way around it, right? There we go. This 1 is touching this mine, and this 2 is touching these 2 mines. So these are definitely mines right here. This 1 is touching that 1, so this is not a mine right here. I think these are mines right here. So this one right here indicates that this is not a mine or this. And I just won. There you go. What's lead CA? Code LSP action. Expand macro false. Yeah. I'm not that smart in NeoVim, to be 100% honest with you, so I don't even use it. So if that's what you wanted to see, that's what it looks like. Okay, so yeah, that's how you win Minesweeper if you didn't know. Okay, so right here, we've already set this up in a prior thing, but basically this is seeing if we had a 9 on the top and we clicked it and there was a mine underneath it, then I'm going to show you these again. So this 9 means we haven't clicked it. And this is a 13. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the array of mines that I have images for, basically. So this is the numbers I'm using. So if this 9 means we haven't clicked on the square yet, if underneath it is this 13 that I've set up to be a mine, then I'm actually going to display this mine right here because we just lost. I just clicked a mine and it blew up. So if the front's 9, the back is 13, I'm going to change the front to 14 and we've lost. And that already makes sense. That's already in the code. If the front is 9, if the back is 13, we're setting the front to 14, right? But we're also going to change the game state. Yeah. This is B, game state equals game lost. Okay. So that was already there. We're just changing it to game lost. And now we're going to add some other stuff here. So we have this if, else. What we want to do, we have this other problem. I guess I'm not going to add this yet. So after we have done the pushback and the board uncover, outside of that if right here, this is where we're going to check to see if we've won or not. Check 1, because like this is where we've lost here. This is any other button. That we've done this in a previous video. But if we've turned stuff over now, after we're done turning stuff over, we're going to check to see if we've won. Okay. So that is checking to see if we've won. I have some other stuff that I'm going to skip over first before we play around with this. First turn. But we're also going to check to see if we've lost. Like right here. I'm going to say, so this one I'm checking to see if I won here. Here I am checking to see if we've lost. And there's a reason why it's not going to be there. It's outside of there. Because we don't want to win or lose on the first move. So if we're not playing, so if the game state is not play, if it's won or lost, right now we're only checking if we can change it here if we've lost, and this function can change it if we've won. So now we're checking have we lost or won. If we have won or lost, we're going to reveal the board. The reveal just reveals where the mines are. Okay, so I think that's enough to test things. Turn true. I'm also going to return. It doesn't matter if I return true from here. Hold on. I'm a bit confused in this part right here because I'm leaving out some code that I'm going to add in later. I have it return true, so I'm going to do that. I can also return true down here. But this one it really does nothing. I don't think I need this. I'm going to comment it out for right now. So I am leaving out the checking of the first move. That's why I'm a little bit confused what I'm looking at. No, this isn't a game engine where I'm just using SDL3 to make Minesweeper, and that's it. I mean, the SDL3 is not a game engine; it's a library. Yeah. So anyway, so let's see what we have got so far with this and see if it compiles. So I was compiling the final code. This time I'm compiling what's in the source directory, and I've made a mistake. Check it out. I didn't prototype the board check one after we made the function. So I need to go up here to this one, board check one, run one, sorry. And I need to put it up here. That's because I'm using a little stricter compiler rules. If you just do a normal build on it, it may not complain. Okay, so let's see if we can win or lose. So we have lost, and it did reveal. It did change the color correctly and revealed the others, but the face didn't change. And I think we can still click. So we need to set that up. So it is the functions that we added, the reveal function and to check if we've won. I mean, the only way to really check if we've won is to win, which would be, let's see. That's a one up there, right? So that's. And that is a 2. I'm just trying to see if it reveals the board. Sorry, I don't want to lose. Okay, so this may be a mine right here. We have 1, 2, 3, 4, 5, 6, 7. Yeah, this is probably the mine right here. And okay, so it is revealing, it is checking to see if we've won because it's just revealed the board. And it is revealing the board on the loss. But what it's not doing is changing the face, and it allows us to keep clicking. So we need to fix that. Okay. And awesome, SDL. Yeah, always always working in SDL development a bit. Always learning some more stuff. So we've done all the stuff in board. What we need to do is go over to game. And I'm going to add, I think just a simple thing. Let's see, game H. we are adding an is playing. So I'm just going to put that with the is running to is playing. So that's all we need there, I think. And I'm going to open up game C. I always have to check my note or I'll forget something and then there'll be some bug or something going on. So I think we're looking at the mouse up mostly. Right. Oh, actually, for mouse down and mouse up, now that we have this state where we have this is playing, I'm checking the top one no matter what, because this is letting us know if we're resetting the game. That's the button. But this is to deal with the board right here. So I'm going to wrap this. This can only be if the game is playing. So we're not going to allow clicks on the board if the game has been lost or won. There'll be no more clicks on the board happening right there. But we can always reset. And we're going to do the same thing down here. This up here is the reset. And this one right here is the, we're going to wrap this one in the is playing. And before I had this wrapped with it too, and I felt like it was a bug, and I think I fixed the bug. So hopefully it's fixed fully. The idea was sometimes it was turning back to the default face when it shouldn't. But now we're going to be actually setting game faces based on if we've won or lost or anything like that. So I'm going to say if board game state so if that equals game 1, we're going to change the face to the winning face, and we're going to change the is playing to false. And I have a misspelling here on face 1. I think I put face won't. I think so. It's going to complain here, if I remember correctly. And we also want to do the is playing to false. Okay, so let's see. Yes. So real quick, let's fix this. We go into face. And I think I put this in the header file and the where here it is, face won't. It's supposed to be face 1. And in the source file down here, face won't. It won't win. Okay, so that should have fixed that. Now we're back in game. I put B here, it should be G. Okay, so let's see here. So if it equals 1, we're changing to the winning face, and we are changing the playing to false. And then we're going to say else if board game state board. If this is equal to game lost, then we want to change it to the lost face. And we are also going to set it to is playing is false. Okay. And then any other time, I'm going to just reset it to the default face. Okay. So I think that is set right. Let me just read what is being said here real quick. SDL is probably one of the most common libraries used for game development. because you can use part of it or all of it. So because it's good for, like, you can just draw 2D objects and move things around and everything else. But also if you're even making 3D games or making them yourself, if you just need to make the window, SDL will make the window for you. It's cross-platform, Mac, Linux, Windows. It will, if you need game events, it'll handle the events for you. If you need sound, it'll do sound for you. So you can do all of the library stuff or just some of them. Yeah, it's quite popular. It's used a lot, but you don't see SDL logo because it's not proprietary. It's open source, so it's not like Unity where you'll see it being advertised all over the place. And it's not a game engine. It's just a library. It just gives you different functions basically to do things, like to open a window and paint something on the window, load an image, things like that. So hopefully this will take care of some of the stuff. We also need to reset. I think I did it, but in game reset, we need to reset those. So the is playing. Is there a game reset right now? Right here. Yeah, we just need the is playing right here, set to true. And I'm not sure if we do the game reset at the top. Let's check. So I probably have it up here, is playing as well. Yeah, I do. Is running and is playing. This is basically just to stop clicks from happening when it's game over, except for the resetting of the button. It stops you from clicking on the board because the game is in the game over state. Let's see if that did everything we need. So I'm going to end the game on purpose. Now I shouldn't be able to click. So first we got the frowny face, which is amazing. And also I should not be able to click here or set. Yeah, I can't click or set anything here. I'm going to click on the face. I'm going to drag it away and unclick. And this should not reset the game because I need to unclick it here. I'm going to unclick it down here. There we go. And it reset to the correct face. So now I'm just going to reset it. And I'm going to slide it down. It resets correctly. It looks correct. Looks like it's running correctly. Let's do a win. Whoops, that was the right way. Oh, so that leads us to the next thing. I just lost on the first turn there. We don't want that to happen. So let's try that again. This could take a couple times. There we go. See, I just lost on the first turn. We don't want to do that. We want to not lose on the first turn. So what we're going to do is if I'm going to click on this and there is a mine underneath it, instead of revealing that it's a mine, I'm just going to go ahead and reset the whole board underneath and then reveal again. So that you never can lose on the first turn. It's going to happen so fast you never see it. Okay, so we need to go back into game, or to board. Back into the mouse button up. Mouse down, and here's mouse up. And right here, we're kind of in this general region. I'm going to check my notes. Oh yeah, you probably use it for like porting that. Yeah, there's there's Doom. Doom is in SDL and everything. Like it's very portable. Basically the SDL people figured out how to make a window in Linux, Windows, Mac OS, everything else, right? And so you can just use the function calls to make the window. They've done all that lower level stuff for you that is a platform specific or hardware specific. So it makes it very, it's quite low level. I mean, it's C and it's an SDL, but think about this. If you've ever made a game in, say, C and SDL, C++ and SDL, if you've ever made a game in Ruby using Gosu, that is also SDL. If you've ever made a game in Lua with Love2D, that's SDL. If you've made a game in Pygame, that is SDL. If you've made a game in Pygame 0, that's SDL. Haskell, you can make a game with SDL. Rust, you can make it with SDL. Odin. I made a game in COBOL with SDL and Forth. So like, yeah, it's like you could do most of the stuff that is like 2D stuff is using SDL under the hood anyway. But pretty much any language that can talk to C can also use SDL. Yeah, like I couldn't believe it. I made a game work in COBOL that was just like blew my mind because I had never programmed COBOL before, and I was like, "Can you make a game in SDL?" Of course you can. And in Forth, that I was watching somebody's video and they were showing that they were saying that you could make a game in SDL with Forth, but they weren't being honest because he literally just had enough code to open a window and do nothing else. So then that took me down a rabbit hole of actually making the bindings to work with SDL so that I could in fact make a game in the Forth language with SDL. So it's pretty interesting. I don't know about Pico 8. I'm not sure what Pico 8 is using. I do know if you look at the what's it called? The Commodore 64, that's SDL. If you're using the isn't the Vert Manager also using SDL? I feel like it's using SDL. I'm not sure. Also the other retro one, what is it called? Something 16, Commander 16. That's SDL. Yeah. Yeah, I've never used Pico 8 though, because I think Pico 8's proprietary or something, so I haven't messed with it. My son made a game in COBOL, in Godot. Nobody really watched the video, but this was me and my 11-year-old son. See here. This is a game he made in. This is not SDL. Sorry, this is Godot and Blender, but it's still crazy.
It's got
like this is insane because he made everything here. Everything you see, he made
all
it.
this one out because I know
he watched a donut video and suddenly he's got spaceships flying around with like
procedurally done by
glass cockpits and stuff, and
some
he's trying to make these
in Blender
generated cities and stuff like that. Just I was like, okay, that's cool. But that's not. I don't think that's SDL though. But it's still pretty amazing. But that was my 11-year-old son. He made that on his own. He's still working on it, but I think he's been modeling like phones and stuff recently. Okay. Yeah. So the one thing that I was going to do here with this code is I was going to add a loop in here so that like if it's your first turn, you can't lose, and it just keeps looping. Let me open up the. No, it's not game. It's board. Uncover. Not right there. So what we're going to do here is if right here when we're checking, right where we start to check whether it is a bad move as we lost the game or we're revealing the board, right here I'm going to do a while true. Just going to chuck an infinite loop here. And the end of this infinite loop will be I got some other code there. First term false. I guess the end of it's down here in the check in the game state right here. Okay, so this is going to run in an infinite loop. And what I want to do is basically if we have the Boolean that it's the first move set, I'm not going to allow it to win or lose. If it wins or loses, I'm going to reset the game before we even reveal anything. So let's see here. On this one, I'm going to say if if it's first term, and the B game state is not playing, that means we've won or lost. Okay. So if we've done that, we're going to reset the game, but we actually I want to change how the reset works, so we're going to change that. But reset can fail, so I'm doing I'm wrapping reset in an if, because reset can actually fail because it's dealing with calloc and stuff that can fail, so I need to wrap that in an if statement. But I'm going to change the reset to have a full and a non-full version of the reset. So I want to put false here, but we haven't set it up yet, so it's going to complain. And this is just return false, because if that function failed, I need to know about it. And that's already set up in this function call right here with this bool right here. So it's complaining about false because that's too many arguments, but we're going to add that argument in. And let's see here. So if this is not true, like if it's not the first term, if these two things are not true, then I actually want to just break out of this loop. And also, when we're done with this whole infinite loop thing, I want to change I could say while, I could have done it differently. I could say while first turn. That might be an option as well. Yeah, I could do that. I'm just going to change it to that. First turn, while it's the first turn, and right here I could say nothing on this one. Oh. No, I can't do this because I need this code to always run, so I'm not going to do that. So anyway, outside of I was trying to go a different route, but I don't want to do it. I'm going to confuse myself. But I need to turn this first turn off if we get out of here. So basically, whenever first turn is set, if we come through here and it is the first turn and we've lost or won, I'm going to reset the board, right? When I reset the board, and then it's going to do it again. It's going to come through this while loop is true. If we don't reset the board, I'm going to break out of here. And then once we break out, I'm going to make sure the first term is false now, so we no longer get stuck in that loop. There's probably another way to do this, but that's just how I have it set up. So we do have this idea of false here. And what it is I want to change the way I reset up here in reset. Uncover. I'm going to add in, wait, that's board reset, yes. Count. So I have this full reset, and right here before basically what I want to happen is I don't need to completely deallocate the board and reallocate it. If it's just a first turn problem, I just need to reset up the board again. I don't need to actually recalculate the board and everything else like that. So when it's a full reset, I do need to do that. When it's not a full reset, I don't need to do that. Because the board's going to be the same size. I'm not changing the size of the board at this point. But other times it will be a full reset because the board will be changing size. So if it is a full reset, I'm going to do all these things all the way down to here. And then, and else. Now on the else, since I'm not recalculating the board, I need to clear the board. And I also need to reset anything that was anything if I've shown the mine basically. Hold on. Okay, so hopefully the microwave is not being heard, but I think it's okay. So what I want to do is basically, since I'm not recalculating the whole board, I just need to blank it out and reset it. So I'm going to go up and grab one of these loops looping through the whole. Where do we have them so many places here? Where is it? For right here, this will do. What function not allowed? I'm not sure. I've done something wrong here. I'll figure it out in a second. That's fine. That's fine. Or oh, this is the on the if it's not a full reset. Yeah. Okay, right down here. It's still complaining about this because of the prototype. That's fine. We'll get it. Okay, so what I want to do is I want to I'm looking at my notes. It looks weird. What did I do? So I know I'm trying to preserve the front of the board. Basically, if I've indicated anything on the front of the board, I am trying to preserve that, because imagine if it's the first turn, I only counted the first turn if I've clicked the left key to reveal a square. If I've put a question mark or a mine indication, I want to preserve that. So I'm just looking at my notes, trying to understand why I did it the way I did it. It's weird. I'm just going to start with the back part. So the back array, I'm just going to zero it out. And the front array, oh, I see. I know what I did. I used a ternary. Okay, cool. So what I did is I created an unsigned, and I just called it L for like element. And I'm just getting the state of the front. So the row column. And now basically I want to set it to 9 if it's not 10 or 11. 10 or 11 is, so I want to set all of them to 9. So basically it could be this. If it's this, I want to reset it. Basically this should be the only option that it is. But I went with, if anything is these two, I'm going to preserve them. Otherwise they're going to be 9. So I'm just going to keep it that way. I know it works, but you could also probably just look for the mine itself. So I'm going to say B front array, row column. And this one is going to be equal to, and this is where I've done this ternary, lm equals 10. Or, and I don't even think I need to put these. I don't think I need to do that, but I'm going to check. Equals 11. So if it's 10 or 11, then we're going to set it to lm. So it just preserves it. Else, it's going to be equal to 9. And maybe I do need the script. First turn. Oh, that's what I'm done here. I put first turn instead of front array. Okay. So I'm back to finding out if I don't need this again. Okay. So the idea, like I said, is I'm clearing the backboard. I am setting the front board to all to 9s unless it's a 10 or 11. Okay. And then also I'm going to generate the mines like we did before. So the mines get regenerated on the backboard. So this is like a soft reset. If this reset is false, it does the soft version. If it's full, it completely destroys the two arrays and recalcs them, because we might be changing the size of the arrays at that point, which will be later in development. We will be changing size. But for this one, everything's the same, but we just need to reset the backboard basically. And anything that's happened on the front board, we need to reset it except those two indicators. Let's see here. I think that is all for that one. We do need to fix it's in the header. This reset right here. Full reset. And this is going to complain any place that we've called reset now, because it's going to need that extra. All right, up here. This is going to be a full reset, so we're going to say true on it. And where we've just added it into the the up button, it was false because it's just the little reset. Where is it? Down here and mouse up. We're doing the board reset false right here. But, excuse me, we also call this in game. There should be an error somewhere right here where we're doing the board reset. And this is a full reset. So it's true. Okay, so now we should have none of this failing on the first turn, but I actually want to know if this has been kicked off. So I'm going to put a little print statement if this happens. So if we do fall into this trap and we're resetting the board, I'm going to do a little print f reset, just so we know visually we can see something happening. Okay, so I'm just going to click the top one down here. And I'm looking down here to see it say something. There it is. Just reset, and we got a 3 here. So this was a mine, and it reset, and we're still fine. It is still like the first move. And I should have indicated... oh, it did it again. So that was a mine again, and it did preserve this, and it revealed what we wanted. So I'm going to do it one more time. It's a little slower this way. I'm using a touchpad on a laptop too, so it feels very slow. There we go. We just got a reset. It preserved this, and it did reveal the 1. So that looks pretty good. And we can lose, yes. And we get the frowny face. And this was a wrong indicator, so that's great. And I'll do another indicator of the question mark here. This is actually a mine, and this is a mine here. And there we go. It doesn't care about these ones, but it does care about the mines that are improperly set. So I think that's that. So we'll just kind of cover what we have been up to. So when I was old enough to use Logo on the Apple II, unfortunately, I didn't have a computer. So I am old enough for that. But I actually started this programming journey relatively recently, like a couple years ago. I did run my own Linux distro some years back, but I didn't have a computer growing up. So the whole idea about microcomputers and stuff like that, I never saw them. We did have Apples in school. I do remember Apple II in the Oregon Trail, which is a game I really want to make. I really want to make Oregon Trail, but I want to reverse engineer the original one. Or I don't want to reverse engineer. I just want it to be the correct information, the correct stats, numbers, and, you know, there is a guy who has reverse engineered it, but he didn't make the source code available, which I love. I just want to see the stats, you know, like the chances of the water crossing and the depth and all the kind of numbers that make it up, and the artwork would be great. And then I'd like to make an SDL version of it. Like there's no Oregon Trail anywhere on GitHub or anything. There's like thousands of them, and none of them are the proper Oregon Trail game. Some of them are the old 1970, what is it, like 72 version or 77 or something, but they're not the Apple II version. Yeah, if you, I would be happy to do it in any language, but I said I just want the Oregon Trail the way it was on the Apple II. That's what I want. Not the basic Oregon Trail that was the paper printout one that everybody copies. I don't want that one. I want the Apple II Oregon Trail. And apparently it was written in BASIC too, but like I don't know how to get that out of it. And I know part of it wasn't written in BASIC, part of it was assembly, the shooting scenes, and other parts were BASIC. But that is a game I would just love to make. But I'm sure it would take a long time and I'd have to figure it out. Okay, so let's kind of like check over what we've done here. So in board, we've added this enum. game state where game play, game won, game lost. These is just 0, 1, and 2, but we can, it's an enumeration. And so we have this enum game state here, and we also have the bool if it's a first turn. And so we've set them in game reset. So here's game reset. At the bottom of game reset, we are setting the first term true and game state playing. We've also changed this because we've added this bool full reset. And basically we're just putting what we've done before in the full reset version, and the else on the non-full reset version, we're just going through the whole board that already exists and setting the backboard to 0 and setting the front board to 9 if it's not a 10 or 11. And then the rest of reset is the same. We have created 2 new functions. There is a board reveal that's used for both winning and losing, and then a check to see if we've won the game. And I call it check, but we're actually setting game 1 state is what we're doing. So on the board reveal, we're going through the entire board, and if the front is 9, which means it hasn't been flipped yet, and the back is 13, which it is a mine, then we're going to show that it's a mine. If the front is indicating that it is a mine because it's a 10, and the back is not a mine, then we're going to show the wrong mine, the X'd out mine, which is a 15. So that's just revealing the board. All we're really revealing is mines, and if we've indicated a mine incorrectly. To check if we've won, all we need to do is to see is every non-mine, everything that's not a mine, is the backboard and the front board the same? As in, is what was hidden now revealed? Have we flipped every square over that is not a mine? Anything that is a mine can have any indication on top of it. It does not matter. It can show a mine. It can show a question mark. It doesn't matter. But everything that's not a mine must be flipped over. So if you have a mine on a non-mine board, you'll never win because you have to flip everything that's not a mine over. And the same with a question mark. You'll never win because you need to flip it over first. So, and if that does happen, it's a game 1. So basically we're checking to see if everything that's not a mine, if the back and the front arrays are equal. If they are, then we've won. And in the up, we've changed a couple things. Basically down here, we've added 2 things. We've right in here, when we know we've tripped the wrong mine, we are changing the game state to lost. And then whenever we are done checking the board, we're doing a board check 1. So whenever we're done flipping over the board, revealing what was underneath it, we're doing to check to see if we've won. So that's new as well. But then we've wrapped this in a while true loop, where if it's the first turn and we're not in the playing mode, we're going to reset. I'm going to remove this right here. So we're going to reset the board, and we're still on first turn basically, and that means we run back through this again. So we're still checking that same spot again. So if I've clicked on one box and that was going to be a game lost and it's the first turn, I'm still going to be checking that same slot again. So it's going to reset the board, but it's going to check that same spot that I've checked already. It's still checking that spot. And if it's a mine again, it's going to reset again. It's in a forever loop until that first click is not a mine, and then it's going to say, okay, now we're breaking out of this. And now we're checking, and now we're changing the first turn to false, so we're no longer first turn. And if game is not playing, so if we've won or lost, we're revealing the board. I don't think we need this here. I'm going to remove it because I don't think we need it. So I think that's everything in there. Let's go check what we changed in the game. We have changed this. We've added this is running. And that is going to be up here. Setting is running here. And I believe on the game reset as well. Is playing, sorry, not is running. Is playing is set in the game reset as well. We've used this is playing to, this top one up here is checking the actual click on the face. This is checking clicks on the board. So these are only be checked if we are in the is playing state. That's for the mouse down and the mouse up. Mouse up, this is only is playing, but this is actually checking no matter what. This is saying if the game is over, we're doing a game over face. If the game is won, we're doing the game won face. Otherwise, we're doing the default face. And I think that's everything. So there's a lot of stuff, but at least the game is working now. We don't have the indicator, we don't have the time running, but we are winning and losing the game, which is really cool. And it does have it where we're not winning on the first turn. We will also be later on we'll be setting different sizes of boards, and we'll be actually changing the what do you call it? The size of the board, meaning how many squares are, but we're also changing the size of the board as in how large it's being displayed, the scale of it. And we're also going to be changing the difficulty and stuff like that. And we are also going to be changing the theme. So those are all upcoming things that we can do with this, but at least we got a game that is playing right now. And on the next one, we'll add in the time and the mine indicator, because then we'll really have a fully functioning game. But let's see if there's any questions. Yeah, Oregon Trail. Somebody could get me, like, I just need to know the stats on Oregon Trail. What's all the possibilities? What's the, like, I don't need I don't need the code. I just need to know all the facts about the game. What the chances of this, that, what's the start out state, how much money you have, what things cost. What's the chances of flooding when it's this deep or whatever? I want that. I want the mechanics, to know what the mechanics are, and then it would be trivial to make the game. The game is very simple, but it's something I'd love to play. Anyway, so that was a whole bunch. If you have any questions, please let me know. I'm trying to edit the video so I can put them up as VODs. There are still a lot of them in the set up in the live right now. I've kind of backlog of live videos that I've done. But anyway, if you have any questions, just let me know in the comments or whatever, and I'll try to answer them. And I hope you enjoyed this, or it was educational. Have a good day, and I'll see you in the next one.